we're going to take a look at how to solve an absolute value inequality. And the solution of absolute value inequalities is similar to that of solving absolute value equations. And this inequality is a less than or equal to. Now, if we just think a minute about the meaning of absolute value, we sometimes say that an absolute value is a distance between 0 and that expression. And when you say that a certain distance is less than or equal to 1 unit, a small distance less than means that you are close in or constrained by the limits of that. When we think of this distance as being represented in only one variable, in this case x, we can consider a number line, and then again a certain distance being restricted, less than a certain amount, means that the distance that we get away from whatever that center point is, again, is going to be limited to the inside. And because we have an equal to symbol in this expression, I'm expecting that my inequality, when we solve it, is going to look something like this. So without actually calculating anything, I can determine the shape of this. A limited distance, which is smaller than or equal to a certain value, is going to have a shape that is close in. Whereas if I had an expression where the inequality were in the other direction, I would expect that, suppose we're greater than a certain distance, that the intervals would be far out. A greater than distance goes again in the other direction, either with the square brackets or with the curved endpoints. So now that I've given myself an impression of what I'm going to be seeing, let's go ahead and solve this. So we're told if k is positive, and we look at the number on the right-hand side, and it is positive, then this inequality can actually be expanded into two inequalities. So the first one is that the expression inside the inequality, which in this case 4x minus 3, is less than or equal to k, which is the number on the right-hand side. So this looks almost the same as the original inequality, but simply without the absolute value bars. For our second inequality, we take a look at this second sample inequality, and we see that x, which is the expression inside the absolute value, so in this case that expression will be 4x minus 3. And now you can see that the direction of the inequality has been flipped, so this becomes greater than or equal to, because our original had an equal to in it. And then opposite of k means, in this case, opposite of 1, which is negative 1. So we'll go ahead and solve each of these. I get 4x, adding 3 to both sides is less than or equal to a positive 4, and then isolating the x, I get that x is less than or equal to 1. So that's my first inequality, and then the second, I'll do the same. I'll isolate the 4x by adding 3 to both sides, and this time we've got the greater than or equal to symbol, but negative 1 plus 3 becomes a positive 2, and then dividing both left and right by 4, we end up with x is greater than or equal to a half. And realize it says here and so that means that both of these conditions has to be true at the same time, and so we're trying to essentially find the intersection of these two different inequalities. So I have values here. If x is equal to 1 over here and this is 0, then x is equal to a half is somewhere in between. And x is less than 1 less than or equal to 1 looks something like this, where we've got the square endpoint. Again, the square endpoint indicating that at x equals 1, that point is included. And next, let's look at x is greater than or equal to a half. So here's our number a half. Greater than goes in this direction, so we're going to be shading forward from the half. But again, we have a square endpoint because the point at x is equal to a half is included. And so when we look at these two regions, the overlap is this very small, where again on the number line we have the points at 0 and 1 and 1 half being halfway in between, and the other end of this interval ending at 1. And so we will shade in between, and that is the solution of this in graph form. If we wanted to write it in interval notation, we would say it's the interval beginning at the point x is 1/2, ending at the point where x is equal to 1. And if we want to write this in set builder notation, we could say that this is the set of x such that on the lower end we have 1/2 is less than or equal to x, and on the upper end we have that is less than or equal to +1.